Thank you very much. Hello again for those who join us. I am Cyprian Moga from Bucharest, Romania,
And
and
I'm
together, yes,
and I'm Miguel Fernandez from Brussels, Belgium.
yes, we are partner in crime. We are both transformation advisor, acting sometimes as consultants, sometimes as coaches, helping companies to move to the next level. We are happy to have here today Barry O'Reilly from Sweden. Barry have an amazing track on software architecture, position like chief architect at Microsoft Consulting Western Europe, or worldwide lead solution architect at Europe, and so on. His life, professional life, is around this software architecture. His company is called mysteriously Black Tulip Technologies, and I'm very curious to know more what your customer are calling you for.
So, so Black Tulip is a company that's based here in Sweden. And it's a company with a very clear mission, and that mission is to redefine software architecture. And that means redefining software architecture as the bridge between two very disparate things: complexity science and systems engineering, two things that actually contradict each other. Complexity science, depending on how you interpret it, tells us that we don't know anything, we can't predict anything, we can't control anything. And systems engineering is the art of predicting and controlling and planning. How do we get these two things to work together? Because we're failing at both at the minute. And so the work of Black Tulip is very much about training and teaching architects to think a little bit differently, to broaden their scope, to pull them out of this world of planning and control, and to embrace something else. It's also a research company, so I'm a PhD student within complexity science and software design with the Open University in Milton Keynes in Great Britain. And there's a consulting arm where I generally do project rescue when it's gone really badly, which is too late, but that's generally where I work. We do teaching, consulting, research, and there's also a software arm, which for the minute is top secret.
We would like to go to the topic of our conference today, transcending the crisis. How software architecture could help this? What is your perspective?
So the things that we've done as software architects in the last 15 or 20 years, the things that we've done in the past all have already decided how most companies are going to handle this crisis in terms of technology. If you want to survive, if you want to thrive, if you want to become stronger because of this, your architects made those decisions for you maybe 15 years ago. And you'll be finding out in the next 6 months, as we're going to see a lot of market turmoil, we're going to see a lot of mergers and acquisitions, we're going to see a lot of companies try to recover revenue, but with numerous different strategies. Their ability to do that, their ability to pivot, their ability to find flexibility and change as the market changes around them has already been decided for them in technology terms by their architects. And hopefully, as we go into this period of chaos, because for software architects, we're going to see a delayed effect here. There's going 6 months, a year from now, there's going to be a lot of demand for software architecture, and there might be a new focus on how we actually do software architecture, because we realize that the decisions, those shortcuts that we took 10 years ago have cost us dearly now. Perhaps we need to start thinking differently about these things as we move into the future. And so transcending the crisis is an interesting topic, because as architects, we're all about transcending the next crisis. And it's a little bit late to be talking about this one right now from our perspective.
I remember an awesome part of one of your presentation on YouTube. You were speaking about a city attacked by a giant reptile or dragon spitting fire. Does it fit with what happens today in software architecture?
It absolutely does. So one of the things I teach my students, and I teach something called Antifragile systems design, which is a pragmatic set of engineering steps that engineers can take to make their systems more likely to suffer unknown forms of stress. And on the flip side of that pragmatism, there's a scientific side to what I do, which is called residuality theory, which is how we look at mathematical structures in the complex spaces around us. The two things are completely married to each other. One of the things I teach my students is that every system you build, the first stressor that you need to think about is that giant fire-breathing lizards are going to come out of the sea and destroy the city in which you're based. That leads to a great deal of skepticism, especially among middle management, because the probability of that happening is almost zero. The lesson I'm trying to teach my students, there are two lessons out of this thing with the lizards. One is that probability is almost meaningless in complex spaces. It's really just a projection of our own bias and what we think is already going to happen. And it's very, very dangerous. And the more limited we are in our view of the world, the more likely that bias is to focus in on technology or focus in on a particular business process and our understanding of that. The second lesson is that if you build a system that survives these lizards, you'll have a system that's also going to survive fire, flooding, social unrest, war, occupation, and pandemics. Because you've already thought about, you're not thinking about probability, you're not thinking about what's going to happen, you're focusing your energy on the sensitivity of the system that you're building. And as you focus on that sensitivity, you change the shapes and the structures of what you're doing, and which is what architecture is. And those shapes and those structures start to become more elastic and start to be able to absorb stress that they haven't seen before. And we teach a way to do that, which is is based on empirical evidence which appears in front of your own eyes. It's not just a trend or a fad or a checklist that you have to do, that the safety science has got into a little too deep. This is an actual empirical method for making sure that your system has a better chance of surviving stress it has never been built to survive, because that's what the world's going to look for in the future. What's happening right now, those companies that are able to manipulate and change and make their systems more flexible, someone will have made decisions based on these residues, based on what's left after stress, based on ridiculous stressors like lizards. And they'll have done that while other people have called them negative, while people have said that's never going to happen and tried to project their bias onto the project. The people who've done that work, who've dissented, who've built structures like this, they're the ones who are going to see their companies be able to transform with ease as we move into the next phase of the next economic cycle after COVID.
From software to, yes, Miguel.
Sorry, I'm interested in having just a broad view about the, I would say, a health checks characteristics of these anti-fragile architectures, because I understood that they should be able to resist to lots of stressors. But if we had to just establish a bunch of characteristics of those systems, what could it be?
Yeah, so if you read the literature, there's an excellent free book by a Norwegian researcher called Kjell Holle, that talks about the anti-fragility in ICT systems, and he recognizes 4 properties of anti-fragile systems: modularity, weak links between those modules, redundancy, and diversity. And those 4 things are absolutely present in all systems that present anti-fragile behavior, that is, systems that survive unknown stressors or survive in some fashion. The problem we have in the IT industry is that because we copy patterns, because we indulge ourselves in cargo cults, everyone's using patterns that give them some degree of modularity, some degree of weak linkage, some degree of redundancy, and it's rare, but sometimes some degree of diversity in their systems. And the problem is that we can't just follow just chase these properties and check a box and say, no, we've done that. We have to actually get to those properties, and we don't really know how. And to figure out how to do that, we go back to Tulip, who talks about the formation of anti-fragile systems through exposure to stress. And so what we do is we stress our system at the design phase, not afterwards, which is way too late and expensive. We stress our system in the design phase and we see these properties emerge, but we don't aim for the properties, we aim to stress. The properties are a byproduct of a design process that focuses on stress rather than functional requirements.
How do we design systems that focus on human proclivities and productivity rather than asking people to adapt to assumptions that engineers made? It's a question from someone who's watching us.
Okay, so that is, we can view that as a stressor, and we should view that as a stressor in all our systems.
A little
people,
lizard.
yeah, it's like a little shy lizard sitting in the bunker writing code. We call them developers. Engineers tend to see the world from an engineering perspective, and we build systems based on what we think the system needs to do or what works for us. There's another balance in this as well. If we invite in other stakeholders and we take in their perspective, if you invite someone in from who has a business perspective, they're going to look for efficiency. They're going to look for cost savings. They're going to look for uniformity across the business. And they're not going to care about the engineer's needs or wants or what the engineer is interested in. On the other side of that, we also have the customer and the employee. And we have to find a balance between all of these things. And they are all stressors. They all affect the system. And one of the stressors you should have is what happens if we don't take the point of view of our employees into consideration and they don't use the system. What happens if the system is too stiff and employees just solve this problem with pen and paper? And that's something that we should view in terms of stress. What will we do if that happens? What will be our path out of this if our employees don't use the system? What will be our path out of this if our customers abandon their purchase after 3 clicks? And that leads to a whole bunch of extra questions we have to ask as architects. How do we know that people are abandoning the system after 3 clicks? Can we actually see that? How do we know that our employees aren't using the system or are unhappy with the system? Which means you have to design more than just the system itself, which engineers don't tend to do. And a lot of that work, which is exceptionally important for anti-fragile systems, falls by the wayside. And it's up to architects and modern architects to educate themselves and to be able to navigate those difficulties and be aware that these things are going to impact your system design more than you're aware of. One of the things I have to do with architects who have, grown up in the industry and built a few applications is to educate them in the fact that the world is so much bigger than you think it is, and everything from the attitude of a customer to the perception of a stakeholder to the tiredness of an employee using your system is a stressor that pushes on your design. And that's vitally important. So understanding your own industry, your own environment, your own complex context with enough depth to understand how it stresses the engineering, that's the key to being able to bring those things into our system design. A lot of engineers are very skeptical about that because it demands so much of them. Because suddenly you have to think about not just code and components, but people and the business and the relationship that business has with its employees and its customers and how they interface and how they interact. And that feels like a big step for someone who just wants to know object-oriented patterning.
And there is a magic potions that we had to offer to the teams that go on commercial and engineering to make work together.
There is, yes.
Sorry, but you get me with this lizard. I have to go into the tails setup. Sorry.
So the magic potion is as simple as educating your architects to understand, firstly, what uncertainty is, because engineers have a very distinct reaction to lizards. They'll get a normal distribution and say lizards are way over here in the tail. That's not something we have to worry about. And when everyone hears an engineer say that, then it makes it easy to discount. So making them aware of uncertainty and the impact that uncertainty can have on their architectures, and the fact that the world is becoming more uncertain and that we work in fat-tailed systems is important. And getting them to broaden out and understand that there's more than just software, there's more than just hardware, there's more than just technology, there's more than just hype, there's more than just process involved here. There are many, many things moving at the same time. Getting an architect to understand that your business isn't the details of all these different aspects of a business, of a software run business. Your job is the interaction between these pieces and what stress can do to those interactions in the environment. Once you make that change, and it's a matter simply of education and encouragement, people start to think differently. And as soon as they start to think differently in the organization, you can never go back. So I usually make a comparison to the film They Live, you know, where the guy goes in and finds these glasses and discovers that a huge part of the human race is actually lizards, coming back to lizards. Once you put the glasses on, you can't throw them away because now you know the lizards are there and you have to learn to work with them.
Barry, I'd like to ask you, how do you capture this diversity in terms of usage? Now, and we had this discussion with our guest Graham before. I mean, we have a larger diversity of customers. We also have a larger diversity of usages and employees that we've seen with the COVID-19. I mean, people are not working the same way and they're not working at the office. How can we deal with that? And what if it changes again? How can we deal with that? And how can we capture those changes?
So we have a conflict here that is very, very difficult for us to manage for a number of reasons, I believe. The conflict is between a growing realization that the world we live in is uncertain and complex. And one of the key ways that we combat uncertainty and complexity is through diversity. Is through trying different approaches to things. That's how humans have navigated complexity for millennia. And unfortunately, navigating complexity in that way means that some of us die while we're doing it. Okay? The reason we know that certain mushrooms aren't to be eaten, certain berries aren't to be eaten, are because our prehistoric ancestors ate them and died in the forests. And the rest of us learned, let's not do this. Diversity is really important. You can't have a society or a business that won't eat any berries and won't eat any mushrooms, because then you're not experiencing anything and you're missing opportunities, and you can't be the one who eats all of them either. There needs to be a diversity of approach, and we're seeing that if you hire for diversity, if you have different perspectives in your staff, different perspectives as an architect, and that's one of the things we teach as well. Get different perspectives. Ask other architects to review your work, see how other people are solving the same problem. Diversity is incredibly important when you're working with complex systems, because no one has the right answer. We build all these myths and ideas that we can predict things, that we can control things, when we absolutely can't. Diversity is incredibly important. On the other hand, we have a business environment, a business culture seated in, and you see this in the MBA schools. It has its roots very, very firmly in the Industrial Revolution. The vast majority of business people in the management class are still in the factory. And diversity and failure are not efficient. And there's a massive conflict between these two worlds. There's an absolutely fantastic book called Complexity and Organizational Reality by a British researcher called Ralph Stacey, where he goes into detail about these conflicts between how we believe the world should work, according to the patterns that we've adopted from the Industrial Revolution, and how the world actually works from the perspective of complexity, and how this mismatch between these two things actually led to the global financial crisis. And at some stage, it's going to lead to an architectural crisis in the software industry as well. So we have to find a way to encourage the business world to embrace this diversity. And they are not good at diversity because we still think in terms of economies of scale. We still think in terms of profit margins and efficiency. That's still what we're teaching at the MBA level. And until ideas like Kinevin and complexity science become more ingrained, more entrenched in the management class, then we're not going to be able to square that circle, so to speak.
That's extremely interesting, but I wonder, how can we, I would say, solve this paradox or live with this paradox? Because if anti-fragility is expensive, it will become very hard to make it adopted for software architects in the business world.
Yes, and this is always the first question I get when I present the ideas on anti-fragility. It's like, we can't afford to fight imaginary lizards, is usually what I hear. And again, that goes back to this idea about efficiency. And what we have to do is to look for those strategies that we would consider convex. These strategies where a small investment can potentially lead to a very, very big payback. And an example of this is the discussion that's going on around face masks right now. A face mask is something that costs a few cents. It's a very small investment. It's not a great effort to put it on. It might not be necessary. There's a lot of debate around that, but the potential payback of wearing it is that you get to live, your life gets to continue, you don't die. And the payback is absolutely enormous compared to the effort that you put in. And so what we try to do in anti-fragile systems design is to find convex solutions to the stressors. And if we can't get the business to buy that we need to spend $100 because of lizards, and they won't buy that because lizards have a low probability, then we have to find a stressor in that family of stressors related to the lizards, like flooding, like fire, something that's realistic to them, and get them to see that as a convex strategy. And then once we start to get that ball rolling, then we start to move towards a system that will express more anti-fragile properties than it would have done originally. We'll never, ever, as architects, as software engineers, we never get to build that perfect system that we envisage in our heads. So there's a whole section of the material on how to navigate conflict between different stakeholders, because eventually we have to come back to people's perception of probability and how we work that in. There's a number of different ways to do that, from the very soft, which is Cognitive Edge's sense maker and how we make sense of narrative, to the very hard, which is MIT's multi-attribute utility, which is engineering techniques that use statistics to figure out how we trade off risks against each other. And there are things in the middle that most IT architects would be aware of. But that trade-off always has to be made. And at the end of the day, what we can do as architects is identify the convex strategies that don't cost us a great deal and move the needle, move the system from fragile towards some form of anti-fragility. We're never going to get the whole way there. We're going to be pushed back a little bit by circumstances, by bias, by attitude, by constraints that we're maybe not aware of on the management level. But at least we can move that needle, and that's all we can ever do. And what my research is working on is seeing that as we move that needle towards anti-fragility, there's a tipping point where we start to solve unknown stressors without really knowing how that's happening. And I've seen that happen anecdotally over and over and over in my career. And that's what I'm trying to get to. Is there a scientific basis for doing this? And if there is, then we have a scientific basis for a new form of software design.
Because we are getting to the end, and I love staying in this legendary setup. Can you find in your box of magic spells something that our audience can take for the software architecture or IT infrastructure and tame it, something that they could maybe use it in the next discussion or next project?
Is it in 5 minutes?
Yeah.
I would say that the nugget of wisdom I have to hand down is that some of the things that you're doing today are creating the circumstances for your fragility in the future. A lot of the things that you trust in, a lot of the things that you believe in, actually create the foundations for fragile structures. So if you believe very much in a certain approach to software engineering, whether that's agile or waterfall or TOGAF or Scrum or some particular one of these religions that we've adopted, belief in these things may be causing you problems. There's a whole world out there of different techniques, and all of them will work in different circumstances. And it's your job as a software architect or someone who supports software architects to make sure that we manage uncertainty and that we don't buy cheap and simple solutions to very, very complex problems. So no more 2-day certification courses. Critical thinking is the key to avoiding fragility in the future for your company.
Wow, that's a hell of a potions. Perhaps we have one more question from the public.
Yeah.
Question from Dana. How do you navigate software architecture? Are there certain situations where you would need to shift focus other than, let's say, security purposes?
I'm not sure if I understand the question.
I think there is a, first, I just read it aloud because just puppets.
Yeah.
How do you navigate software architectures? Are there certain situations where you would need to shift focus other than, let's say, security purposes? I think the question was around, can we move beyond security purposes to navigate software architecture?
Well, I think that, you know, as software architects, I'm saying that in the past, we believed that software architecture was about the choice of components and and how we structure those components. What I'm saying is that it's software architecture is actually about the relationship between the IT system and everything around it, and that's the security concerns, performance concerns, market concerns, social and political concerns. All of these things push on the software architecture structure, and when they push on it, we have to. That's when we decide what the component structure is going to be. And so being a software architect, according to my definition of a software architect, means that we don't just get to sit and draw lines and boxes and decide on components and use someone else's patterns. It means that we actively have to be involved in navigating security and navigating performance and navigating market changes and in understanding the impact of a change in an exchange rate on our architecture, which means that we have to step outside of our box all the time. Doesn't mean we have to be experts in everything, because some architects have tried that and failed miserably, but we need to understand the interactions between all of these different people, and we need to be able to work with experts in different fields, from economics to supply chain management to security, in order to be able to find that balance. Software architecture is much bigger and at the same time much smaller than we actually think it is.
If we take this posture, shall we integrate the software architects, I would say, in the marketing team or in the finance team? Or how do you see the place of the software architect into a company?
Yeah, so the software architect will have to move around between all of those teams and have to be able to have sensible conversations with those teams, and relate those conversations back to the structure of the software system. That's the only way that we're going to get it to work. What we've seen happen in the last 15 years is that ask is fairly big. It's a fairly big ask of our software engineers to be able to do that. Some people have shied away from it because it feels like it's too much, and that's because we've tried to become experts in everything instead of experts in the interactions. We don't need to be marketing experts, but we need to understand the impact that marketing can have on our software architectures. We need to understand the impact of the decisions that the finance department can have on our software architects. And it means that we need to be part of a team that delivers more than just software. It means that I, as an architect, don't want to be part of a team that delivers a software system. I want to be part of a team that delivers a product or a service to customers into a market. And that's where software architecture has to be. We wouldn't want our finance people working in the bunker on their own, doing finance that they tell us in 6 months hasn't worked. We shouldn't be doing the same thing with our software architects or engineers.
Well, our time's up. I'm so sorry because I was feeling so good in your land of legends of software architecture.
Thanks a lot.
Thank you very much, Barry.
Fantastic.
And looking forward to having you again.
Yep. Thanks, guys.
Thank you, Barry. Good insight. Thank you.
Thank you, Barry. That was an excellent conversation.